Welcome to the Biostatistics review for Module 13. In this review, we'll be talking mostly about the kinds of questions that will show up on a standardized test. This is not everything that you learned in Module 13, but it's focused primarily on the questions that you could be asked that are multiple choice. And so there are three basic areas that we'll be asking you question. One is variable type. The other is selecting the best test, and then finally interpreting the results. Now I'm including variable type questions because this is the basis on which everything you are able to do in statistics is based. And so again, you'll be having a few questions. For those of you who have learned this and understand it really well, then this will be easy questions, easy points on your test. So again, we have the different variable types, D for dichotomous, N for nominal, O for ordinal, IR for interval ratio. And dichotomous simply meaning di meaning two, so that means you have two categories that are possible. N for nominal, nom representing name, so nom or naming. So nominal variables, you simply are naming categories, and there are three or more categories for nominal variables. And specifically, they are not in any order. They could be things like eye color, they could be different schools a person goes to, it could be different disorders, like if a person has different diseases, disease states, that kind of thing. Ordinal, on the other hand, those are categories and they are in order. And so that would be a situation where you have three or more different groups and they fall into a natural inherent order. And so low, medium, high, any kind of Likert scale where it's on a scale of 1 to 5, what is your pain, what is your happiness level, what is your stress, those kinds of things. Those fall into a natural order because of the inherent nature of something that's ordered. Those three collectively, dichotomous, nominal, and ordinal, are our categorical variable types. And then on the other hand, interval and ratio are the continuous variable types. And we, for the purposes of this class, don't make a distinction between them because it doesn't make a difference in terms of what test we are selecting, what type of statistical analysis we would run. There is difference between them, but we consider both of them to be continuous variable types. And the flag of that is that there is almost always a level of measurement. And so you might have blood pressure in millimeters of mercury, height in inches, those kinds of things. As soon as you see a scale for the measurement of that, then you would automatically be thinking this is probably an interval ratio variable. So interval ratio is continuous, dichotomous, nominal, and ordinal are categorical. Now that information is going to help you when selecting the best test. In fact, the three different tests that you have to choose from that you know of so far all are dependent on having a dichotomous, nominal, or ordinal variable. We cannot run chi-square tests, either the goodness of fit test, test of independence, or the Fisher's exact test with anything other than categorical variables. So if you were given a situation where you were asked for one categorical variable, does this fit an equal distribution, or are all the categories evenly represented in the population, or specifying particular percentages like we saw in your homework 40, 30, 20, 10, then that would be where we have a goodness of fit test. There's only one categorical variable, and it could be ordinal, could be nominal, could be dichotomous. We only have one variable that we're testing against some kind of standard or reference or expected numbers for each of the categories. On the other hand, a chi-square test of independence, or could also be called the chi-square test of association on your exam, on your CPH exam, the chi-square test of independence requires that you have two categorical variables, and that can be any combination. It could be dichotomous with ordinal, could be ordinal with nominal, could be two dichotomous variables. two nominal variables, two ordinal variables. And what we're wondering is, are those two categorical variables related to each other? Are they independent from each other, or are they associated? So those are just two different ways of asking the same question. So that's your chi-square test of independence, where we have two categorical variables. Now let me jump down here to what can you do if the chi-square assumptions are not met. So those chi-square assumptions, really the main chi-square assumption is that the expected value for each of the cells should be at least 5. And there are different cutoffs. Some people will say at least 80% of the cells have to have an expected value of at least 5, or that kind of thing. So if that assumption is not met, it depends on what size of table you have. Let's say you have a 3x5 table and one of the variables is nominal, one is ordinal. Well, the thing that you can do in that particular case is that you can collapse some of the categories that are smaller with either their neighboring category, or maybe there are some categories in race ethnicity that are just very small or 0. If we use the national government guidelines for race ethnicity, I think there are 20-some categories, and it's very likely if you have a small sample in your particular sample that you may have some that you have none, that you don't have any people in that particular category. So we often will collapse categories together. So that's one thing that you can do. Specifically, if you have different race ethnicity, sometimes, or something similar to that, we might collapse several different categories into other. Even though they aren't necessarily similar, that would give us the numbers that we need in order to be able to run a chi-square test on that particular research question. And so it may not be a perfect solution, but collapsing categories, either adjacent ordinal categories or different nominal categories that are all small somehow, or that can be a fix if the chi-square assumptions are not met. Now, a special case of when the chi-square assumptions aren't met is if you have two dichotomous variables. In other words, your predictor or your health determinant is dichotomous and your health outcome is dichotomous, or even if they aren't predictors and outcomes, if you have two variables that are both dichotomous and you have the situation where one of the cells has an expected count of less than 5, then you can do a Fisher's exact test, and that's where that test is going to come into play. That particular scenario that's given to you will tell you something about how the expected count for one of the cells is not at least 5, and it's a 2x2 table, and that's where you would choose the Fisher's exact test. The final piece where a lot of questions actually come from is related to this interpreting results. Now what happens is you'll be given some kind of output or the results section of a paper, and you'll be asked on a variety of different levels how to interpret that. And this is actually a very common skill that you will use quite a bit probably in your public health career, regardless of what the specialty you are focused on. And so regardless of your major within your MPH. And so you may need to look at results from published literature or for program findings, that kind of thing. And you'll need to know how to interpret that so that you can know if that's something that you can use in your practice. So you'll be given this output or the result, and you'll need to say, is it statistically significant or not statistically significant? Do I reject the null or do I fail to reject the null? Are the variables independent or are they not independent? Are the variables associated or are they not associated? And so those are the kinds of things, and often it'll be a combination of those, and that will be similar to the multiple choice questions you had in the modules previously. And so the bottom line is that you're going to be looking at the p-value, and making that determination. Now, for those of you who understand the difference between statistically significant and clinically significant, when they're asking you to interpret the results here, they're not asking you about clinical significance. That is an important feature, and we will be talking about that as we progress through the quarter. But for the purposes of multiple choice testing, typically they're more interested in asking you about statistical significance and if you can interpret what that means. So, if you're given a question that's like that, what you need to do is you need to look at the p-value. If the p-value is less than 0.05, then that's where you would say, yes, that is statistically significant. I reject the null hypothesis. It looks like the variables are related to each other. And so that's kind of like the interpretation that you have with that. If the p-value is greater than 0.05, then that's when you would say it is not statistically significant. I fail to reject the null hypothesis. It looks like those variables are independent of each other. And so that's kind of the decision-making process in terms of statistical significance. And that applies equally to the goodness of fit test. If you have that, whether, we're asking whether things are equally distributed or some other distribution, it is or is not evenly distributed. And so that's the kind of thing that you would need to do in terms of interpreting the results. Now, talking about that whole hypothesis thing, I wanted to clarify something so that you leave this module really understanding this. One of the things I did not teach well in the previous module is about what happens when we have more than two categories. It's easy, like the sample one that I gave you, when we talk about smoker versus non-smoker. Well, if smokers is 18, then non-smoker would be 82%. So that kind of captures all possible scenarios. However, as soon as I have more than two categories, which is one of the examples that you had for your assignment, this was one of them. The distribution of exercise at baseline for people with none, mild, moderate, or vigorous exercise is 40, 30, 20, and 10% respectively. And so as soon as you have more than two categories, then the alternate hypothesis is best worded a little bit differently than the way we word it if there are only two categories. And the way we say that is that at least one of these exercise groups does not meet the above distribution. And this at least one is kind of the key to understanding this. And it's because the null hypothesis and the alternate hypothesis have to capture all possible scenarios. And so if we say just at least one of them is not equal, the other ones could be distributed that way, but one of them could not meet it. So let me give you an example of how that could happen. So here we have our none, mild, moderate, vigorous. Here's our 40, 30, 20, 10. And let's say that instead of 40% in our sample, we end up having 42% in the none category. That doesn't seem very different. Then probably that would not be enough to say that it's statistically significantly different. It's different, but we're wondering, is it statistically significantly different? Let's say this is 32% and this is 22%. What does that leave? That leaves for our vigorous exercises only 4%. And so while this is only 5% different, this is like 7.5% different, this is 10% different, this is 60% different between 10 and 4%. That's a big change, and that may be enough of a change to trigger the Chisquare test to say statistically significant, reject the null. Whereas these other ones, the 40, 30, 20, those are not very different from their predicted numbers, their percentages. And so here's a situation where one of the exercise groups doesn't meet the above kind of distribution, but the other three kind of sort of do. And so that's why we say just at least one exercise group does not meet the above. If we stated it that all of the above were not met, then we would have a situation where the null and the alternate do not capture all the possible scenarios, because maybe some of the time, some of the categories do meet that distribution, but only one of them doesn't. And so this is kind of a minor point, but important in terms of really thinking about how the null and alternate need to be complementary to each other. And so this clarification issue is not on the test. You won't be writing alternate hypotheses. This is a multiple choice exam, but and that's not the kind of thing that typically is tested with standardized testing. But I just wanted to make sure that as you're leaving Module 13 that's clear. You will see this again. This at least one is not the same. And that's when we're going to get to our Way Anova. So in our next module for statistics, you'll see this. And this is any time we have more than 2 categories. As long as we have just the 2 categories, then we can state the null and alternate hypothesis as kind of like equal or not equal kind of a thing. But as soon as we have 3 or more categories, then we have to use this at least one kind of terminology. So good luck studying for your exam. That concludes our review of Module 13.